And thank you to the Tsleil-Waututh Nation for the invitation to speak here today. I'm really excited to share about some of the work that me and my colleagues have been doing at the Changing Oceans Research Unit at the University of British Columbia. Today specifically, I'm going to be talking about two different studies. One done by my colleague Lauren Weatherton back in 2016, and an update to that, my thesis work, which hopefully I'll be graduating in the next 2 weeks. So feel free to ask me a lot of questions today as a practice for my defense. So without further ado. So ultimately, this is what I hope that you'll take away from the talk. And so the question is, what are the projected changes to First Nations fisheries by the year 2050? And so in order to do this, Lauren Weatherton sampled 16 First Nations community along BC's coast, and this accounted for the 7 coastal administrative zones by the BC First Nations Council. And so from these 16 First Nations communities, she sampled 98 species, and this encompassed fish as well as marine invertebrates from both the food, social, and ceremonial fisheries as well as commercial fisheries. She wanted me to stress that these 98 species is not a complete representation of the species of importance to First Nations community, but merely serves as a way of understanding some of the trends that we might see. So how do we model these 98 species? Well, we use species distribution models. And so I'll give a bit of a background for how we do this. So for each marine invertebrate or a fish, there's a specific thermal preference or tolerance that they're able to live in, and this is indicated by the circle. As the ocean conditions get warmer or deeper, when they get warmer, the salinity changes or ocean acidification, as we heard from this morning's talk, we might see local extinction. We might also see species moving towards higher latitudes and deeper waters in order to stay within this thermal preference. And this is named climate-shifted distribution and is modeled by the dynamic bioclimate envelope model, which is the model that Lauren and I both used in our analysis. So in addition to temperature, this model also accounts for salinity, changes in primary production, and we modeled this under 2 climate emission scenarios, as was mentioned in this morning, the RCP 8.5, the high emission scenario, and the RCP 2.6, the lower emission scenario. And so generally, this is the trend that we see. The figure on the left shows temperate oceans, and so we see species moving from the tropics into these waters, and the figure on the right shows tropical oceans, and we generally see a decline in species as species move towards the poles. And so we can do this on a global ocean, and this is extracted from my supervisor, William Chung, from the Intergovernmental Panel on Climate Change. And so this shows the changes in catch potential for the global oceans. So basically anything in blue means plus gains in catch potential, the winners of climate change, and anything that's red or yellow, they're gonna be the losers of climate change. And so what I wanna stress is that this figure shows all of the world's fisheries, both large scale as well as small scale. Now, what we are interested in looking at is specifically British Columbia and specifically First Nations fisheries and the small scale fisheries. So that's the question. So what did we find? So this was presented by Nathan earlier before the lunch break. And so this is Lauren Weatherton's study, and she found that there's going to be a decline in catch potential for First Nations fisheries. Out of the 98 species, 87 of them have projected declines. And this includes the Pacific herring, that includes roe herring, spawn on kelp, food and bait fishery, as well as salmon. And so for salmon, there's going to be a 29% decline compared to the year 2050, from present compared to 2050. And while I know not everything is measured in terms of economic terms, just to give you an idea, that goes between 16 to 29% loss in revenue for the First Nations fishery by the year 2050. But it's not all doom and gloom. In fact, for 3 out of the 98 species, we see increases. Specifically, that's Pacific sardine, with a 42 to 44% increase by the year 2050. We see Manila clam with increases as well as the white sturgeon. And so potentially these species might be more adapted to these warmer waters and are able to thrive in these new ocean conditions we will see on the shores of BC. As was mentioned earlier in the talk, there's going to be a shift of species northwards, and this shift is further exacerbated in the higher emission scenario. And that shift we see, it's between 10 to 18 kilometers movement up north per decade. So that's fairly vast. And then unsurprisingly, northern communities are less impacted by this change as species move up north. But I just want to highlight that all of this is still within the negative range, so they're still going to be experiencing losses, although the magnitude of that losses is relative based on the latitude. Okay, so that was done in 2016, and now for my thesis, what I've done is to look at the rest of BC. So is what we find for First Nations fisheries indicative of what is happening across the region? So I take 303 species, which account for about 75% of the catch within BC. So what did we find? How many people say it's gonna be the same, declines? Show of hands. Okay, a few people. How many think it's gonna increase? Okay, I like it. There's a few people who think that there's gonna be positive changes, and you are right. In fact, for the rest of BC's coast, for small-scale fisheries, there's a projected increase in catch potential. So you're probably wondering why, because what we've heard is that there's gonna be a loss in catch potential. And this change is further exacerbated in the 8.5, the higher emission scenario. We're gonna see more gains in catch. And so I was wondering the same thing back in December when I was doing my thesis, and I thought I'm gonna have to add on another year to my thesis to disaggregate this apart. But I looked at it by species level. And what we find in species level, so these are the top 10 species in BC's water according to catch. You will notice for California market squid and cannonball jellyfish, these insane projections, they are within the magnitude of between 500 to 1,500% increases in these waters. And so the California market squid and cannonball jellyfish are extremely adapted to these warm water conditions that we will find off our coast in the near future. So what are these species? Cannonball jellyfish is an important species to the Mexican fisheries right now off the coast of Baja California, and California market squid is an important species to the fisheries of Monterey Bay. They are commercially extremely important. And so these are recent headlines from newspaper articles within the past month. And if I could direct your attention to the bottom right, that shows the egg casings of California market squid washing up on the shores of Oregon. And this is to inform the public of what this is, because this is an extremely rare sighting. They've never seen this before. So could this be the start of climate change's effect taking place off of our coast already? Finally, everything that I've presented up until this point is just comparing two time periods, 2000 and 2050. And so I want to show you the rest of the time scale. What does it look like? And generally speaking, we'd see this increase for BC's fisheries up until the year 2080, as far as my study projects. But that trend really starts to pick up, as was mentioned in this morning's talk, as the time period goes on. And so that's going to have implications for fisheries, both in terms of nutrition and food security, especially because in the first study by Lauren Weatherton, those 98 species that was modeled did not account for cannonball jellyfish and didn't account for California market squid with these tremendous increase. So what might it look like in the future where these species might potentially occur off the coast of our waters? What would that mean for First Nation fisheries as well as other small-scale fisheries to adapt to these changes? Our research group at UBC is also actively looking at the economics and the price of these, the fluctuation, as well as the ability of these communities to adapt to this in terms of gear changes, in terms of their food security, whether they have the the licenses and stuff to continue catching these fish. So we are really excited to continue the collaboration with the Tsleil-Waututh Nation, as well as anyone else in this room. We are happy to continue this conversation after this presentation. Finally, just want to leave you with a conclusion slide. I want to say that everything I presented on here, I know I say it with some certainty, but obviously these are models and they're projections, and so there's some uncertainty, which I'm happy to discuss more later, as well as if you have any questions, please, for my thesis, come ask me. I'm happy to talk about it. Thank you so much.